Okay. Today marks day 7, which completes a week of coding every day to prepare for full time. Today is Sunday, June 1st, which is the start of June, so exciting. We're getting closer to the start of summer. When is summer solstice? Summer solstice 2025 is June 20th. So the day's about to get real long. And then after that, they're going to start shortening up a bit. But yeah, definitely exciting. Got June happening, which kind of means I got about 2 months from now to sorry, try to prepare as much for August. I mean, probably 3 months because interviews don't really start until September. Some interviews might happen in August. OAs will happen for sure in August. So that'll prepare me for OAs, which would be good because there's gonna be a lot amount to apply to. Today, my girlfriend comes back from New York. She was taking a trip to drop off her younger sister. Because her younger sister is doing some pretty cool stuff in New York. Actually, in Philadelphia. Right? No, Pennsylvania. What am I even saying? I'm all over the place. So that was pretty cool. I'm excited to see her today. So I'm gonna try to get this video over with quickly. We're probably just gonna run these 3 easies, and then call it then. So run these 3 easies. We'll finish that. Hopefully, make this just a short video, so that way I can go ahead and sorry, go see her. So starting off today, we're going to be doing a reversed linked list. Now, it's been a minute since I've actually programmed a linked list, but let's actually pull up the Figma. And let's do. Oop, I gotta sneeze. Ugh, sorry. Okay. Sorry. I'm feeling real sneezy right now. So for a linked list, if you don't recall, it's similar to, so a list in memory is always going to be kind of right next to each other combined. So in like a statically typed language like C++, when you make a list, you will declare its size and then it's that size for good, right? Because it's putting a section of memory out. So then whenever you want to make a dynamic array, something that can change in C++, you would have to make kind of like a class for that, where if you want to add something, it's going to go basically make a new array, and then it's going to add these values, right? And then it's going to take a new value and add that new value, and then it's going to delete that and then set this to be the new value. It's going to return this, right? So that's how you do dynamic in C++, because you want the you want the arrays to grow and shrink accordingly. Now, this has some benefits. It also has some negatives. So if you wanted to, let's say, remove this value here, it can be kind of tricky, right? Like trying to pop a value from the middle. You have to go and linearly pass through, go like x, x, then you reach this, and then you delete it, right? And then you have to basically take this x, move it here, and this y, move it here. So that kind of causes extra time. While on a linked list, what you'll do is you'll store the nodes like that. They're kind of like their own thing. So you'll have one part which has the value, and then one part that has the pointer. Okay, so this has a pointer to this x, so it goes here. This has a pointer to that x, so it goes here. This has a pointer to this y, so it goes here. And this has a null, so it points to nowhere. So that is like a linked list. So if you wanted to pop this, instead of having to move everything, all you have to do is you just take this arrow and then you move it here, and then you then you delete that, and then you delete this, and it's popped. Constant time, which is nice, right? Maybe the part that's not constant is having to find a value, because you might have to parse through to find a value, but other than that, it's constant time. Which is nice. So in this problem, given the head of a singly linked list, so that means there's just like one arrow. So a doubly linked list would be like if this arrow, let's Control Z real quick. So a doubly linked list would be, so for example, this one points to this one. A double linked list would be previous arrow. So if there was a previous arrow too, which these have their own uses, which the use for these cases is that you can go backwards. So I can go. You can only follow the arrow, right? You can't go without the arrow. So now I can go both ways. That's a benefit of a doubly linked list, but it then requires more space capacity, and then it can also get a little bit more convoluted whenever you're trying to delete stuff, because now you have to make sure that whenever you're deleting things, you're deleting it properly. But it has benefits. So. Oh, sorry. Given the head of a singly linked list, reverse the list and return the reverse list. Okay, so I'm given, here you go, a class of list node. So head is optional. I've never seen this type of description before. Like click print head. Is it gonna do anything for me? Holy shit. That is interesting. It prints the whole shebang. So if I say like print head dot val. Oh, don't forget your parentheses. Am I tripping? How to get the type of a variable in Python. I'm like, okay, so it's just type. What is happening? I've never seen optional before. I've never seen this. I'm a class precompiled list node. Okay, so it should be head dot val. Am I like not understanding how to do classes properly right now in C plus Python? Class and then type. Man, what are we talking about right now? Okay, Oh, is it that the head is a null? Is that what the problem is? Okay, here we go. Here we go. So this is giving me an empty list, man. Okay, thank you. All right. Okay, I see. Okay, so this is how we're going to do it. I'm gonna say current equals head. I'm gonna say are we returning a okay, no, we're returning a node. Thank you, right? A linked list can be reversed either iteratively or recursively. Can you implement both? Yeah, why not? Sure, let's do that. Okay, real quick. So let's actually talk about reversing it, so we can see it. So we have 1, 2, 3. That's all we need. So for example, let's say we're at 1. We'll then go. We'll store 1 equals like a previous. Okay. So wait, let's write this out. Okay, so I'm gonna say previous equals null. Okay, and then current equals 1. So I'm gonna say next equals 2. So what I'm going to do is I'm going to say that current dot next is going to equal previous, and then I'm going to say current equals next, and then I'm going to run it again. So then what I'll have is, so right now this is the start. So I'll say 1. Oh wait, and then hold up. I'm gonna say previous equals current. Okay, so then I'm gonna have 1 equals to null, and then I go to the next one. So that's 2 equals to 1. I go to the next one, and that's 3 equals to 2. And that's how I'll do it. So basically I'm gonna say while current does not equal null, or better yet, none. And let's stop the damn parentheses. Holy crap. While current is not equal to none, I'm gonna set up some guidelines. So I'm gonna say previous is equal to none. And I'm going to say, actually I don't need to declare next here. So I'm going to say next is going to be equal to current dot next. I'm going to put a little underscore here because it's like being weird. Sorry. I just take a consistency when I add these underscores. And then I'm going to say current dot next is going to be equal to previous. I'm going to say previous is now equal to current. And then I'm going to say current is now equal to next. Okay. And then at the end I'm going to return current. Oh, sorry. Oh, there you go. Let's see, hold on. I'm texting someone real quick. Oh yeah, apologies. So yesterday's video might be coming out a little late. It's coming out today actually, and that is because my Wi-Fi was down yesterday. So I was able to record it, and then shortly after, I went downstairs, ate lunch, and then Wi-Fi was out till like 11 p.m. And I totally forgot to post it until today. So I recorded it yesterday. I just didn't get to post it because Wi-Fi was out. Okay, so this is iteratively. Iterative. Let's do it recursively. So it should follow the same logic. I'm gonna write it here. I'm gonna say recursive. Def recursion. Trying to think of like what I want to take in here. I'm gonna take probably the self and then node of optional list node. Okay. I would just do current and previous. So I'll say basically if current is equal to none, then return previous. And then else, what I'll do is I'm gonna say next node is gonna equal to current dot next, and then current dot next is going to be equal to previous, and then previous can be equal to current, and then current is going to be equal to next node, and then I'm going to return recursive of current and previous, and we'll turn that. Runtime error because I'm not calling it. We're going to return recursive of head and none. Still runtime error. Oh, because I'm doing a misspellage. It's a little confused. Like, what are we trying to do? Runtime error because I'm missing. Oh, because I put wait, no. Huh? Maybe get rid of that, because it can be null, but null should be allowed to go anywhere. Yeah, you have something. You got none. Come on now. Do we need to get rid of the self? Like, what? How is that the error? Alright, that's, I'm a little confused on that. Maybe I need to set it up on my Python classes. But there you go, that's recursion. Really simple, really easy. So I'll check that out, and then some more merge choose sorted list. Oh, great. Doing merge sort. I actually kind of like merge sort, but it's been a while since I've done it. You're given the heads of two sorted linked lists. List 1 and list 2. Merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked list. Okay. Is there a time constraint on this? I mean, I should be able to merge O of n. Because I just kind of like go through, or O of n plus k. N, k. Which then I could say that m is equal to n plus k, and that's O of n. So then time-wise, O of n is equal to O of n. I hope that made sense. With time complexity, like if it's all the same linear passing, then it'll all be the same as things expand. Merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged link list. Okay, so does it want me to do this recursively? No. Alright, so they're already sorted, which is nice. Now basically what I'm going to do is I'm going to say current 1 is equal to list 1. Current 2 is equal to list 2. And now I'm going to basically go do a while loop. So I'm going to say while current 1 doesn't equal none and current 2 doesn't equal none, I'm going to basically go through. So I'm going to say, hey, if current 1 dot value is greater than current 2 dot value, then I'm gonna take the smaller value, which is current 2 dot value. I'm gonna plug that into the new list. So I'm gonna say new list is new list is equal to list node. Is that how you do declarative? I think that's how you do declarative in Python. I usually don't like mess with many classes in Python, so. And then I'm basically gonna say new. Oh, hold up. New list head, and then I'm gonna say current new is going to be equal to new list head. Okay, so because we're working on pointer magic, basically going to say that wait, this is pointer magic, right? Or am I tripping with the C++? Shit. We'll see. Yeah, we'll see. Current new dot value is going to be equal to current 2 dot value, and then current new man, what am I? Why am I blinking up real quick? Current new dot next is going to equal, it's going to be a new list node. I'm going to say current new equals current new dot next. Okay, and then I can also do that at the end. Oh, this is like actually chopped right now. Wait, hold up, this is chopped. I'm gonna have some like some weird jank going on. Oh wait, this is so chopped. Hold up. Okay, hold on. I need to do some testing real quick. Okay, wait, that works. No, that does not work. Sorry. It's not work. What I'm doing right now is just copying the values. But instead, I could just like actually make it the node. So what I could do is I could say is equal to none, right? And I can say okay, perfect. Let's see if this does this in place. Or if I'm gonna be trilled. I could very well be getting like trolled right now, so we'll see. I have an idea how to fix that though. So there is no current.next. So what I'm going to do is I'm going to say current new is going to actually be equal to current 2.value. And then I'm going to say Oh yeah, this is gonna be chopped. Ooh. I'm having my brain's having a little bit of a hard time wrapping itself around these pointers, which is it's unfortunate, honestly. Okay. And then I can do I think there's a part of this is actually pretty chopped. We're gonna see real quick whenever I actually return the head. It's probably gonna be broken. An int object has no attribute next. Oh, that's because I'm assigning it the val. What am I doing? No val, no val. Actually, I don't need to see val at all for like anything unless I'm checking the weights of stuff. I'm having a feeling it's gonna return none. None object has no attribute next. Oh, because I'm doing. Duh. Okay, so just the current 2. Okay, so it's returning none. Yeah. Expected. 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 I'm gonna call this this just holds a pointer to the next position. I feel like I'm the really fuck. I'm cooking up right now like bad on my pointers. Because I need to assign it. Do I start from the back? Why am I like tripping on this? This is like extremely easy how this works, but I'm messing up my pointer logic. Mainly because I haven't messed with pointers in 2 years. That's been a little bit of time. So the problem is I'm not assigning the next pointer correctly. I'm assigning it, and I'm thinking that I'm assigning it to the memory space, but no, I'm not. I'm thinking of C++, which assigns it to the memory space of a variable. I'm only assigning it to the value of a variable, which is not helping me out. So I need to assign it to the memory space of a variable. So I'll have to do something like a current new dot next is equal to that. And then I'll have to do like current new is now going to be equal to current new dot next. And then I'm going to make sure the next is none. Actually, I don't even really need to do that, but for the sake of it, why not? Okay, so that worked. Using proper pointer math, that worked. Okay, there you go. That was silly that it took me a second, but yep, that worked. Basically what's happening here is I just check each value and then I assign it properly. For the pointers, I'm having to make sure my pointers are actually set before I kind of go to the next area because I'm not setting it to memory space. I was assuming I was setting it to memory space, which was an incorrect assumption. I'm only setting it to the value of the memory block. So, yeah, that trolled. Okay, now on to the last one. Linked list cycle. So, given a head of the linked list, determine if the linked list has a cycle in it. There's a cycle in the linked list if there is some node that can be reached by continuously following the next pointer. Internally, position is used to denote the index of the node that tails the next pointer is connected to. Note that position is not passed as a parameter. There's a cycle in the linked list where the tail connects to the first node, 0 indexed. So wait, does position exist? So print head dot position. Yeah, it has an attribute position. Well, hold on. Internally, POS is used to denote the index of the node that tails. What? What is this? Hold on. Who wrote this? Internally, position is used to denote the index of the node that tails next pointer is connected to. Dude, I literally, this is like giving me an aneurysm reading this. Who wrote that? That was I feel like either I'm really dumb or that is extremely poorly written because I cannot read what they're trying to say here. Of the node that tails the next pointer, so it's behind the next pointer, I'm sure, is connected. What? Is that my hint? That like, hey, like you should print out. Is every single value unique? Because if it is, then I'm fine. Because look, okay, if every single value is unique, I can do this. I can make a dictionary. I'm gonna say this is a dictionary. I'm gonna call it has been equals this dictionary. Okay, and then basically I'm going to say that while head does not equal null, I'm going to run this, and what I'm going to do right here is I'm going to return false. Because if I go through this whole loop and I haven't crashed out, then that means there is no cycle. That means I reached the end of cycle. Okay, so basically I'm going to say if head dot value is in has been, then return true, because that is a cycle. Else has been of head dot value is going to equal to true. This just basically means that I'm keeping that accounted for. And then I'm going to say that head is equal to head dot next. This only works if there are no duplicate numbers, because if there are duplicate numbers, then it breaks. Okay, so here I wrote true and it should have been false, and there are duplicates. So that's why. So there are duplicates. Okay. So I need to get a value that is not the value but the position. The thing that's pissing me off is like, how am I going to annotate this position? Like if I wanted to do this, the smart way you would program this is in the class you would put a position value. Right? Because all I'm going to because like look, okay, I can kind of like make a guesstimate of what position will be based off the current value and the next value, right? Not really, because I could have negative 1224 and then negative 1224 pop up twice. Internally, position is used to denote the index that the node's tail's next point is connected to. What about if I don't think I can hash through that. That's like so gonna break. I'm pretty sure that's not hashable. Oh, it is hashable. It worked. That can't be right. All right, this problem is upsetting because design-wise, it's just not smart. This is an Amazon interview question? Sure. Oh! Oh, shit! Fast and slow. Oh, dude, I didn't even think about fast and slow. What? So this is what I did. I did the hash set. Dude, I totally forgot about fast and slow. Fast and slow is so cool. While fast and fast.next. Dude, I love fast and slow. You know, I'm gonna code fast and slow just so I can remember it. I'm gonna say this is the hashed version, and then I'm gonna call this fast and slow. Okay, so I'm going to make I'm gonna say slow, fast. They're both going to. Slow is going to be equal to head. Fast is going to be equal to head. And I'm basically going to say while fast does not equal none, and fast.next does not equal none. Then I'm going to run the algorithm, and at the end I'm going to return false. And basically I'm going to say before I even start off, I'm going to move them. So I'm going to say slow equals slow.next, and fast is going to equal fast.next. So it moves a little bit faster, as it sounds. And then basically, if fast is equal to slow, then return true. Oh, I gotta spell it correctly. Return false. Oh, come on, man, be nice. Okay, that is fast and slow. Uses less space, and honestly is a prettier solution. Nice. So there you go, fast and slow, which pretty much does every single permutation. Is it really ON though? Like really, is it actually ON? Because I feel like it's a little bit more than ON. Because it kind of like fast and slow kind of does like every single permutation. Alright, cool. Alright, I'm going to call it there. That was a quick video. That was only like an hour or so. Just 3 easies. I checked that off, right? I did. Okay. So yeah, just did 3 easies. I guess tomorrow we'll be looking at some of those more mediums. We'll finish up those mediums, and then we'll do probably like 2 mediums here. Not all tomorrow, but you know, like what are we doing? Maybe like 2 mediums here, 1 medium here, and like maybe 2 to 3 mediums here. And then after I finish those mediums, I'll move on to trees, tries, and backtracking. And then I'll probably like after doing, I think I'm gonna like, so I'm gonna leave like some of this, like, you know, leave these out, leave that out, and like leave that out. I think later on I'm gonna come back, like I'm gonna do easies, mediums for everything here. And then once I hit a certain point, then I'm gonna come back and I'm gonna do the last mediums and the last hards. That's probably near the end, and that's gonna suck ass. But it is going to have to be done regardless. I feel like a hard, I'm going to have to do like on its own day. Like the whole day is dedicated to a hard. So let me make sure I have all the hards set up. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I have 21 hearts.
Sheesh. Alright,
Oof. Well, let me think. We'll do a new notepad. So there's 21 hearts. Okay. I kind of want to do the hearts for their own day. You know? So I'm tracking. There's gonna be 30 days this month and 31 in July, right? I think so. So I've got like 61 days. 60 if you're not including today. So 60 days to do that. So that'll make 39 to do the other rest. I've done 18 out of 150. So that gives me 132 that needs to be done. Minus 21. That's going to give me 111. And I have to divide that into 39 days. So 111 divided by 39. Okay, 3 a day will get me right. 3 a day will get me right. So yeah, if I just do 3 a day, I should be fine. Curiously, let's do 39 times 3. That gives me 6. So there's 6 days where I could just do 2, I think. That's what that means, right? So 33 times 6 plus 33, god damn it, 33 times 3, 33 times 3 plus 12. Yeah, that gives me 6 days where I can only do 2. Some days I could do 4, which gives me an extra day to do just 2. But let's try not to use those 2 days much, because don't want to abuse it. But okay, that gets me right. All right, I'm going to end it there. Thank you for watching, and I'll see you tomorrow.